My name is Harman Slot. I work as a senior project leader within TNO, within the unit Energy and Materials Transition. In my day-to-day work, I try to improve our knowledge, expertise and portfolio related to carbon capture, transport and storage systems. Together with my colleagues and research partners, I try to help the industry realize their climate goals through consultancy and research projects, and by doing so, aim to make transport and storage systems more cost-effective, reliable and safe. Here you see the TNO Colorado flow loop, which is a research infrastructure developed by TNO. With this research infrastructure, the flow and phase behavior of CO2 can be researched, either on pure CO2 or CO2 with some impurities. Now, this type of research is very important to the industry because CO2 as a fluid behaves a lot different than other gases commonly used by industry. Therefore, this research infrastructure is very important because it allows us to accurately study the flow and phase behavior of CO2 with and without impurities at pressures and temperatures that are relevant to CCS applications. The Colorado flow loop allows us to do research into the flow and phase behavior of CO2 with and without impurities within a wide range of pressures and temperatures. It also allows us to evaluate material properties under various conditions and to identify safety risks. This flow loop has a design pressure of 100 bars and can sustain temperatures down to -40 degrees. This implies therefore that conditions that are representative to CCS applications can be reproduced with this flow loop. Because it is a two-phase flow loop, the main components include a compressor, a pump, a separator and a cooling system. In essence, it consists of two parts. First, there's the test section, which can be custom made in order to investigate any type of process that involves flowing CO2 somewhere between where it's captured down to where it's stored. Second, there's the control section, which aims to maintain the properties of the CO2 flowing into the test section at target values. We can do these tests for pure CO2, but also on CO2 with certain impurities like nitrogen, hydrogen, argon, methane and carbon monoxide.